So good afternoon, everyone. I'm Siyuan Zhou from Siemens Corporate Research, and I'm going to talk about the Siemens version of the local energy gateway. When I saw this topic, the first thing come up to my mind is, why do we need to control the plug loads using some controller? Because before that, all the stories are about decentralized appliances. Here's the status from a survey conducted in this building last year. And from the left side figure, you can see that we have various kinds of the appliances. The most important one, the purple one, is the HVAC, which we can control by the smart energy box just introduced by Prasad. And there are the nanofab, which we cannot control, and some other servers and coolings and some others for other buildings, or the water heating system, which we cannot control. And the last part that we could possibly control is the lighting and the plug loads. And if we go to the pie chart on the right-hand side, you could see that the light and plugs contribute 14% of the entire power consumption, and in which about half of which is contributed by the plug loads. And if we're talking about energy reduction of 30%, then we cannot just ignore those percentage. That's how we can maximize the demand response in a building. So if it's necessary to control the plug loads, how do we do it? Here is the setting that for the demo we just did upstairs. And we want to control those plug loads, but we want to control it smartly. What do I mean by smart? I want to enable two aspects of this controller. One aspect is that it has to talk to the smart energy box, because smart energy box is the brain of this building. He is the one that can get the demand response signals, can get the weather information. He's the one that can read the meter of the entire building, which knows what the power consumption is. So if anyone who would set out command for plug loads, it would be the smart energy box. From the other aspect, because we're controlling the plug loads, which is around every user, so we have to let the users to participate in here. And in this case, if we assume that each of the gateway was controlling, for example, one office zone, then we want the user to put in preference. We want to gather sensor information, and so that the gateway would then decide which of the appliances that it would turn off. So talking about the communication with the smart energy box, we are using an agent-based framework called JADE for the communication and negotiation. We call it the negotiation because the gateway is not just simply applying a control which I got from the smart energy box. What the gateway got is just a number that after the negotiation, the smart energy box would give me a number. This is the number that I would want you to contribute to the entire power reduction. But how, which of the appliances to turn off, the gateway would then, considering the user preference, the current status of all the appliances, and then make that decision. And all this is has to be happening inside a negotiation, because the gateway has the ability to refuse it if the user doesn't want it. About the factors that was taken into account for the negotiation for the gateway, the user preference is the first and foremost important to us. And the user could choose that this appliance is so important to me that I don't want it to be participating into the demand response. And he can also set if some appliance is more important or if it's less important. Some other thing that we want to take into account is also the sensor data. For example, we have the lighting sensor, occupancy sensor, and if we want to control the lighting, for example, at some task lights in my office, then I would then read the sensor data if there is somebody in the room, and if the lighting level is already very low. If it's already very low, then it doesn't make sense to turn off every light. So in that case, I would not turn off the lights. And of course, the real-time power usage of each of the appliances would be taken into account. And with all those constraints and preferences, the gateway would try its best to meet the demand constraint sent from the SEB. How do we collect the user preference? And also, as a user, I would not only want to provide my preference like a day ahead or whatever, I want to provide it in real time. And if I change my mind, I want to be able to change it. And also, the gateway to me is just some black box, but I want to know what it's doing. So we have to come up with this web-based user interface to monitor all the status of the gateway and each of the appliances, and to enable the ability for the users to change his preference, or I decided to plug in a new device, or I decided to unplug in another one. So from the left-hand side, you can see there are the overall information of the gateway, the total power reduction, total power consumption, and if there is any reduction goal sent by the SEB, it would show in a power reduction goal. Also on the left down corner, you could see the sensor information collected from the sensor in the room, and that yellow one in the middle would reflect the event time information. That means that if I get an event from the SEB, for example, you want me to reduce 500 watts for the next 15 minutes. And in this block, it would show you what is the start and end of that time, and when the gateway wants to apply control. That's how I expect some of my appliances might be turned off or something. And then on the right-hand side, you can see that we show the details of each and every appliances. If you click on that tab, you would see the information of that appliances. And also from this UI, you can add or delete appliance, and you can change your priority, which goes to the user preference. If you set it as critical, then the gateway won't turn it off. So that's about what I want to tell. Is there any questions?